Alright, what do we have here? We have a radius. We have a force, so that's a little different. And we have a mass. So the way I look at this one is you have force gravity, you have force normal, and this force of 220 is just kind of the, if you want to think of it, the tension in the arm or the force applied by the arm. This 220 newtons will equal, force applied. If you want to think of it that way, we'll put an A there for force applied. Let's even see if we need the y. So let's start out with the x. Sum of the forces in the x. Since it is accelerating, it's mv squared over r. The only force in the x direction is the force applied. So that's mv squared over r. Boy, am I getting sloppy here. The velocity, how fast, that's the question mark. Okay? So that's the question mark. Let's get v all by itself, and then we'll put numbers in. Doesn't matter when we do it. So it's going to be v squared equals force applied, which is that 220, multiplied by the radius. And that's radius divided by the mass. And then we'll square root both sides. So the force applied was that 220 newtons. The radius was 80 meters. And then the mass was 70 kilograms. And we'll square root that. So let's throw it in the calculator. 220 multiplied by 80 divided by 70. Square root answer. And I get 15.9 meters per second. And so that's the first one, meters per second. And then I'm going to just come over here to try to save save a little space here. 15.9 meters per second. And there's 1,609 meters. In 1 mile. And remember, this is seconds. And there's 3,600 seconds in 1 hour. So seconds is bye-bye, bye-bye. And meters is bye-bye, bye-bye. So now I have miles per hour. So let's throw all this in the calculator and see what we get. So 15.9 divided by 1609. Hit enter just for fun. Let's multiply that by 3,600, and we get 35.6 miles per hour. That seems reasonable, doesn't it? All right, next one.